Okay, so I just want to take a second and I want to step back and talk about what a regular polygon is. Regular polygons have all congruent sides and all congruent angles, kind of like an equilateral triangle or a square. So, speaking of a square, here's a square. That's a regular polygon, a regular quadrilateral. Here's a regular pentagon. Notice all the angles are the same, all the sides are the same. Here's a regular octagon. All the angles are the same, all the sides are the same. So, what we know about a square is that the measure of an exterior angle is going to be 360 divided by 4. Now we know that because every single exterior angle is going to be equal because it's a regular figure, and for any polygon it's always 360. So for the regular pentagon it would be 360 divided by 5, which is 72. And notice that that 72 is going to be the supplement of the 108 in the interior. And for the octagon, it's going to be 360 divided by 8, which is 45. Okay? In case you have forgotten some of the terms, I just want to emphasize a regular polygon has equal sides and equal angles. And there's some of the regular figures are an equilateral triangle, a square, a regular pentagon, a regular hexagon, a regular heptagon. That's what a 7-sided figure is. 8-sided figure is regular octagon. That's easy to remember, right? Octopus, 8 legs. Regular nonagon, 9 sides. That's one that kids don't hear very often. So 7 is heptagon, 9 is nonagon, and 10 sides is called a decagon. So now let's do a little bit of a table to reinforce all of these ideas. Okay? So what are the sum of the interior angles of a square? It's going to be, it's always 180 times the number of sides minus 2, which is 360. What about the sum of the interior angles for a pentagon? That'd be, again, 180 times n minus 2, but this time n is 5. So it's 180 times 5 minus 2, or 540. What about a hexagon? Remember, a hexagon has 6 sides. 180 times 6 minus 2, which is 720. And what about a decagon? Remember, a decagon has 12 sides, like a decade has 10 years. The decagon will be 180 times 10 minus 2, or 1440. Now, what about the sum of the exterior angles? Well, that's easy. Every single time, the sum of the exterior angles is 360. Now, how do we find the measure of one interior angle of a regular polygon, like a square or a regular pentagon, regular hexagon, regular decagon? You just divide by the number of sides that there are, because the number of angles is always equal to the number of sides. So this is interior angles, not exterior angles. So the interior would be 360 divided by 4, which is 90, and that's what we see in a square, right? We know all 4 angles are 90 degrees. What about a pentagon? Well, that would be the sum of the interiors, because we're doing interiors. 540 divided by 5 this time, which is 108. And hey, that was the measure we saw in the diagram. Next up, hexagon. 720, but divided by 6, which is 120. And for a decagon, it was 1440 divided by 10, which is 144. Okay? Notice a pattern here. As the number of sides increase, the measure of an interior angle increases. Now, what's the measure of one exterior angle? Well, that's, believe it or not, it's even easier, because the sum of the exterior angles is always 360. We just divide by the number of sides. So 360 divided by 4 is 90. 360 divided by 5 is 72. 360 divided by 6 is 60. Hey, did you notice something here? Did you notice how the 90 and the 90 are supplementary? The 108 and the 72 are supplementary? The 120 and the 60 are supplementary? I bet you, what's the supplement of 144? It's 36. Let's see if that works. 360 divided by 10, I forgot the divided by symbol there. It is 36. Cool. We notice some patterns. Here we're going to emphasize the supplementary nature. Here's a triangle, and we said before that it's an equilateral triangle, and there's the exterior angle on the outside, well, there's your interior angle, and then your exterior angle is always supplementary to the interior angle. And it's true whether we draw an equilateral triangle like this, or when we drew the regular pentagon before, or if I drew a regular decagon. If I just take one of the sides and extend it, I automatically make a supplementary situation. So notice that supplementary relationship between the measure of one interior angle and the measure of one exterior angle. All right, let's do a little so far summary for the new material for today. The sum of the interior angles of a polygon is 180 times n minus 2. The sum of the exterior angles of a polygon is always equal to 360. And to find the single interior or exterior angle of a polygon, divide the sum by the number of sides.